All right, the title of this MAA talk was Correcting Social Scientists' Misimpressions of Hypothesis Testing. This is the name of the paper that we actually submitted. This is joint work with my student Vince Miller. The way this came about, Vince was taking a class with a social scientist in our university. He came to me with a graded homework paper and some things about hypothesis testing, and he showed it to me, and I said, this is wrong. So I went to the professor and to talk to him about it, and he said, well, that's what my book says. And so I asked him to look at the book, and lo and behold, that is what the book says. So that kind of led into further investigation, and we find that, in fact, errors in hypothesis testing in the social sciences are common, not just in practice, but in the very textbooks that are used to train social scientists. So I think this is a problem that deserves being pointed out, and I will show you what's the deal. So a summary is that social science textbooks on statistics rarely introduce the concept of conditional probability in their discussions of hypothesis testing. And really, this is a key concept, and trying to express hypothesis testing without understanding conditional probability is bound to get you into trouble. And you see that they often do fall into trouble. Instead, social scientists use imprecise terminology that's easily misinterpreted, and often by the authors themselves. Sometimes textbooks themselves abuse the terminology and make false statements. These errors have persisted for decades. This is not, there's a paper back in the 70s or 80s that points this out. The only way to correct these errors is to change the terminology to more accurately reflect the underlying concepts. The mistakes have persisted too long. We can't just try to give better explanations. We simply have to change the terminology because it's too prone to error. Okay. So let me start with the concept of significance level. Significance level is a conditional probability. Okay, so this is from our paper. The significance level is the probability that a null hypothesis is rejected in an experiment, given that the null hypothesis is true for that experiment. Now, the significance level is set before the experiment. Another way you can refer to this is rejecting a true hypothesis is also referred to in the social science literature as committing a type 1 error. Okay, so we could write this as alpha is the probability that type 1 error is committed in the experiment, given that the null hypothesis is true in the experiment. Okay. Now notice that this is a conditional probability, conditioning on the fact that the null hypothesis is true for the experiment that you are going to perform. Now, in fact, you never know whether the null hypothesis is actually true for that experiment. If you knew, you wouldn't be conducting the experiment. Okay, so this is a conditional probability based on a condition of which you are ignorant. Okay, so this can lead into trouble. Unfortunately, often in social science textbooks, this alpha is referred to as the probability of type 1 error. No condition is mentioned, least of all the fact that this condition is not even known by the experimenter. And the fact that social scientists don't refer to the condition often leads into trouble and confusion. Okay, this is poor terminology, and I claim and I urge that this significance level start being referred to as a conditional probability. Okay. Another related concept is p-value. Now, p-value is sometimes explained as a probability. If you do so, this will often lead again to confusion. Okay. Now, you can explain p-value as the minimum significance level alpha, which the experimental result indicates that H0 should be rejected. Okay, you do your experiment, you compute a p-value from the result of the experiment. If that p-value is less than alpha, you reject the null hypothesis. Okay, if the p-value is bigger than alpha, you do not reject it. If the p-value is alpha, that's the minimum significance level, which then that's the minimum significance level where the experimental result indicates that H0 should be rejected. Okay. Now, there's another expression. People talk about p-value being the probability of obtaining something at least as extreme. Okay. And the problems with this is that you're actually talking about an experiment that is not performed. You're talking about probabilities for a hypothetical experiment in which the null hypothesis is true. Too often, people take p-value as a probability involved in the experiment that's actually performed. So if you talk about p-value as a probability, you're bound to induce errors in comprehension. Okay. P-value says nothing at all about the probability that a type 1 error has been committed in the performed experiment. Nothing at all. Okay. So it's better not to call p-values probabilities at all, because if you call them probabilities, they're bound to be misinterpreted in some such way. Okay. All right, so here's an example of an error. So if you take a look at this text, here they do a statistical test. They compute a z-score. They don't compute the p-value in this case. They have a z-critical of plus or minus 0.96. You can see this two-sided with 5% significance level. And he says that the decision, he says as a result, they reject the null hypothesis. Then back here, it's correct to reject the null hypothesis. Then they have this conclusion. The decision to reject the null hypothesis has a 0.5 probability of being wrong. This is simply not correct. The alpha is not the probability of type 1 error. Alpha is probability of type 1 error given the null hypothesis is true. You do not know the null hypothesis is true. This is just simply not relevant and not correct. Similar error here. You have define a significance level. There are some definitional problems here, but it says if the p-value is less than 0.5 or 5%, it means we have a 5% chance of being incorrect in rejecting the null hypothesis or having a type 1 error. It's because they're calling alpha the probability of type 1 error. They don't refer to the condition which is not known, namely the condition that the null hypothesis be true in the experiment. Okay, so again, they come to the same error because they don't talk about conditional probabilities. All right, so let's look at this one. All right, here you say the amount of type 1 error we are willing to risk as the significance level of a test of statistical significance. Notice there's no mention of type 1 of conditional probabilities here. It sounds like alpha is going to be the probability of a type 1 error when you perform the experiment. Not true. Simply not true. Okay? The estimate of the risk of type 1 error that's associated with rejecting the null hypothesis in a test of significance level is called the observed significance level and is ordinarily represented by the symbol p. P is not an estimate of the type 1 error. It's simply not. If you work out the expectation of p, it has nothing to do with the type 1 error of the experiment. Okay, so they by failing to mention the condition and by trying to interpret p as a probability, they've fallen into error once more. And these are not old books. I'd like to point these out. These are books that are still in current use. Okay. All right. Here we have. We can express a conclusion by saying that p, type 1 error probability, TP, is not the type 1 error probability. Inferred from a study is less than or equal to or greater than alpha. Statistical significance level corresponds to the highest tolerable cutoff for type 1 error, as pre-established for the investigator. Okay, so this is simply identifying p with type 1 error probability is incorrect identification. Okay. So here they make the same wrong conclusion. The statement can be interpreted as follows. There's a less than 5% probability that the rejection of the null hypothesis represents an error. Simply not true. Okay. Okay, here they say that if you have an alpha as 0.05, you're going to have a false positive outcome about 5% of the time. Again, not true. Not mention the condition. Null hypothesis being true, simply not true. Okay. Again, here they say having a p-value of 0.05 means that a type 1 error will occur roughly 5% of the time. Okay, just not true. Okay. So this, if we take this sentence, if we set our alpha level to the conventional 0.05, then the probability we will reject the null hypothesis wrongly, that is, make a type 1 error, is also 0.05. Okay, later on he does mention that this probability is conditioned on the presumption that your null hypothesis is true for the experiment being performed. But because he doesn't mention that here, it's bound to be misunderstood by students. Okay. Okay. Again, no mention of the condition. No mention of the condition. Here they don't mention conditional probability. They just say even though, which is ambiguous. Okay. And here, just point out again, problems with not introducing the notion of conditional probability. Okay, so my recommendations, don't try to interpret p-value as a probability. P-value is a minimum significance level that leads to rejection. Don't call significance level probability of type 1 error. It's a conditional probability based on a condition that's never known to the researcher. Teach conditional probabilities. Insist that every statistical assertion be expressible as a mathematical statement involving conditional probabilities. And I close with this paragraph that I flash up here. There are numerous errors in this paragraph. The writer is trying to use informal language to give people an intuitive idea. Now, I just put out this statement that for a mathematician, our PR challenge is to design terminology so that even non-mathematicians will draw correct conclusions even if they don't fully understand what they're doing. It's kind of like driving a car. We have a car, we have diagnostics. We don't need to understand how the car works, but we do need to know how to drive. We have to create terminology so that people who don't understand what's going on still can use the terminology correctly. All right, thank you for listening.